Hello everyone and welcome to ABB RobotStudio tutorials. In this tutorial we first explain how to insert a 3D object or a simple geometry to our workspace. Then we explain how to define a workobject coordinate systems, which are also known as workobject coordinate frames. And finally we explain how to move in the newly defined workobject coordinate frames. But before we start with explanations, let's first explain the main motivation for creating this video tutorial. Namely, let's imagine this real-life scenario. Let us suppose that we want to move the tip point of our end effector or our tool that you can see over here along the edges of this box. That is, we want to move this tip point along this edge, along this edge, along this edge. Or let us also assume that we want to move this tip inside of the top plane of this box. For example, in real life you can imagine that this tool is actually a welding tool and that we want to move this welding tool along this edge. That is, we want to weld the two sides of this cube. Or on the other hand, you can imagine that this is some kind of a laser cutter or some kind of a laser tool, and that we want to basically perform some task or to follow some path that is inside of this top plane of this box. Now, what's the issue and what's the difficulty of performing these tasks? If we formulate our robot tasks in the global frame or inside of some base frame that's usually attached to this point over here, then this assignment becomes very hard. And the issue there is that often you don't know the rotation angle or even the position of the box. That is, someone can place the box somewhere in the robot workspace. And then you will need to spend a lot of time and a lot of calculations to figure out what is the equation of this line. That is the equation of this line or the equation of the edges, right? And this is very difficult. To illustrate you this, let's suppose that we manually do these things. And currently, I'm jogging inside of the basically UCS, right? This is a base coordinate system, and you can see over here the coordinates. So over here, if I move along x-axis or along y-axis, I'm actually not moving in parallel to the edges of this box. That is, it's very difficult to move in parallel to the edges of the box. Let's try to do it over here, for example, or let's say over here. So it's very difficult to do that. If you now zoom in, how are you going to move? Okay, you can move x in this way, but then if you want to follow the edge, what do you need to do? You need to somehow change x and y at the same time and somehow to synchronize them. So it's very difficult. Okay. And also you don't even know the height of this box, right? You can only guess. Now, instead of doing this and instead of using the base coordinate system, you can be smarter. You can define a new coordinate system that's shown over here, whose sides are actually aligned with the edges, or better to say, whose axes are aligned with the edges. For example, this is the x-axis, it's aligned with this edge, y-axis is aligned with this edge, and z-axis is simply perpendicular to the plane. And now look what I will do. I will now activate this coordinate system. And how to do that? I will simply change this option over here, and look now, magic. So let me first position at 0, 0, 0. So I will reset 0, I will actually reset x, then I will reset y, and you see, and z, here it is. So I'm in the coordinate system. So if I want to move along the x-axis here, look what happens. Magic happens. And let me increase the step size so you can see it better. You see, magic happens. Let me zoom out. So you're moving along this edge. So let's move along y. We can simply see it like this. So we move along y. Okay, very easy, right? And then somewhere in a plane, if you just specify x and y, we will be somewhere in this plane. For example, 50-50 point will bring you this point in the plane. That is, we are now moving in this coordinate system. This is a coordinate system that I actually defined manually, and this is our work object coordinate system. And in this video tutorial, you will learn how to precisely define the work object coordinate systems and how to jog or move the robot in the work object coordinate systems. This is a very important technique for programming ABB robots as well as other robots. Okay, so let's start from scratch. Once you open RobotStudio, you will see this main screen. If you don't see this main screen, then press New. Then click on Project, and over here, do not click on Include a Robot in Virtual Controller, simply click on Create. We will later on include a robot and a virtual controller. So click on Create and be patient. Okay, the first step is to add a robot. To add the robot, click on the ABB library and click on the robot and click OK. So here's our robot. The next step is to learn how to zoom, how to rotate, and how to pan the view. To zoom the view, you need to use the middle mouse button, which usually has a roller. So simply move, or better to say rotate the roller forward and backward, and you will be able to zoom in and zoom out. Another approach for zooming in and zooming out is to hold the middle mouse button and to move mouse left and right. To rotate the view, press Ctrl, Shift, hold Ctrl and Shift, press the left mouse button, hold the left mouse button, and move left or right your mouse cursor. And this is how you rotate. To pan the view, press Ctrl, hold Ctrl, and press the left mouse button and move left and right. Okay. The next step is to add our virtual controller such that we can move our robot. So click on the virtual controller, click on From Layout, click on Next, and let's just choose the default settings. Click on Next and click on Finished. Now wait over here until you see a green status over here. This will take some time. Okay, so we are good. Next, we need to add our end effector. To add the end effector, click here on Import Library, and over here I will select the training object, and then I will simply select pen. Of course, you have some other options over here, however, let's not explore these options currently. So let's click on pen. And over here you can see the contour of the pen. The issue with this pen right now that it's not attached to our robot. To attach the pen to the robot, click over here, do the right click, and then click on Attach to, and click Attach to our robot. Do you want to update the position of the pen? This is very important. Click on Yes, and magic happens. Here's our pen. Let's now rotate so you can see it better, and here it is. Good. The next step is to add a 3D object to our workspace. To do that, click on Modeling, and over here, click on Solid, and click on Box. And over here, I will define the box. First of all, let's define the length, width, and height. Let's do 300. Don't press Enter still, just move your mouse to width, and height will be 300. Okay, next let's define the corner point. The corner point should be 200. 200 over here, and let's define the orientation, and let the orientation be, for example, 35 degrees. Okay, now you can click on Create to create the box. So here's the box. Next, let's change the color of this box. Click on the box, do the right click, and let's change the color. So how to change the color? Well, there are several options to do that. You can basically click on Modify, and you can set graphic appearance. Over here you can click on Simple Color. So for example, let's choose this color, and let's click OK and click OK. Now we change the color of the box. I like this color better. Okay, so what is the next step? The next step is to define a work object. And this is the most critical step in this whole tutorial. So you need to carefully do that. So to properly define the work object, let's first move the robot. So click on Home, then click on jog joint, and over here let's now rotate the robot by clicking here, hold the left mouse button, and let's do this so we can clearly see our box. Good. Let's close this create box dialog, and let's click on home again. To create a work object, you need to click on other and click on create work object. Okay, so if I click here, you'll see this menu over here. Now, over here you need to scroll down and to find frame by points. So click over here, and we have two options for defining our work object frame. We are going to use the 3-point method, and I will explain this method by doing this example. So, what's the idea over here? We want to place the coordinate system center at this point over here. And one axis will be along this edge, another axis will be along this edge, and the third axis will be perpendicular to the top plane of the box. So let's first of all read what's written over here. First point on x-axis. Okay, so we need to specify the first point on the x-axis. Click here. And now it's very difficult to select this edge over here. So to properly select the edge, you need to use the snap tools over here, and I will go over them. So over here, first of all, you need to select surface selection. This is very important. So click here, and another snap option that you need to select is to click on snap edge. Now if you come closer to the box, you will see this small sphere over here, or a point. And if I move my mouse cursor, you can see that I'm snapping at the edge. That's a very important step. Otherwise, you will not be able to define your coordinate system if you do not turn on the snap option. So let's click here, and let's select the first point on the x-axis to be somewhere along this edge. For example, this point. And you can see that the coordinates are updated. And these coordinates are actually in the world coordinate system, or in the base coordinate system. Now you can see that automatically we are moved to the second point on the x-axis. Let's select this point, and we need to define the point on the y-axis, and let's say that this is the point. And do accept and click on create, and see the magic happened. So here is our coordinate system. Here it is. Now, if you now deselect this one, you can see that this coordinate system is a little bit misaligned. It's not exactly misaligned, it's just wrongly rotated. And that's the issue with this coordinate system. So let's learn how to properly rotate these axes such that they match these z, y, and x. We can see that x is right now like this, y is correct, however, z is not correct. So we need to rotate this coordinate system for 180 degrees around y-axis. So let's learn how to do that. But before we explain how to rotate this coordinate system, it's first important to explain how to find in this menu over here this object. Okay, to do that you need to click on paths and targets, then you need to expand controller 1, then you need to expand T-Rob1, and over here in T-Rob1, under the work objects and targets, you will see work object 1. And if you click over here, you will see that it's being highlighted in our view. Okay, now if you expand it once more, you will see the work object. So select this one, and not the top one, do the right click and click on rotate. And over here, we have an option to rotate. Let's select the y-axis, and let's specify the rotation angle 180. And click on apply, or you can simply click on close. Don't click on apply. If you click on apply, the issue will appear. Just click on close, since you already applied this. Good. Let's continue. Now we define our work object 1. The next step is actually to move the robot inside of this work object. So how to verify the robot movement? Well, let's see that. Now, if I click on layout, and if I click on my robot, I will have an option over here to move and rotate. So let's see how to move and rotate the robot. I don't want to move and rotate the base, so I will simply select over here, and then again move and rotate, and I will be able to move my end effector like this, linearly. However, you can observe what's happening. I'm moving in the global coordinate system, and I'm not moving my robot in my newly defined coordinate system. Okay, now obviously you need to change the reference. You need to go from world to Workobject 1. So here you can have active Workobject. So what is the active Workobject? Well, let's see. Over here you have Workobject 1 and Workobject 0. So let's select Workobject 1. That's the Workobject 1 we just defined. And click on active Workobject. And let's see now what happens. What happens now? Let's see. Very interesting phenomenon happen. Well, you can see that this linear axis, that is this x, y, and z, actually are parallel to x over here, y over here, and z over here. That is, they become parallel to our coordinate system. And now simply you can move this one, you can move this one, and you can move z as you wish. Now, before you even do this further, it's very important to explain the following. This is not the best approach for moving the robot. And why this is not the case? Well, I don't like this type of moving the robot since it can clog the view and you can reach some end points or some singular points. Consequently, this is not the best approach. So over here, click on World. The proper way for moving the robot and for making sure that you're actually moving along these edges is actually to select over here your robot. Then you will see this mechanism tools window, click on modify, and over here you need to select the proper option. Now, if you select here mechanism joint jog, what will happen? You will see this window over here, and then with this window and this basically slider, you can manually set the values, and this is very important. However, we are currently moving in a joint mode. We don't want to move like that. We want to move our robot in the coordinate system we just defined. So let's see how to do that. If you now click over here, you will bring this menu. Okay, so you will bring this menu, and this menu is very important. Now, again, to bring this menu, I simply clicked over here, then clicked on modify, and over here I clicked to bring this menu. This menu is very important since over here you can specify the coordinate system. So if I click over here and expand this drop window, I can select my Workobject 1 that we just defined. And now all the coordinates over here of my TCP, that is of this point over here, are actually represented with respect to this coordinate system. And this is very important. Now I can set, for example, proper values. So for example, I can set x is 0, I can set y 0, and let's try to set z 0. And let's see what will happen. You cannot change z, right? We are just above this point for the z of 400. So what's the issue over here? Well, the issue is that this tool is in a very difficult position and you cannot properly move the robot up or down, since if you try to rotate one of these joints, it will not be possible to go along this line. That is, you reach some form of singularity of your robot, and you need to correct that. To fix this issue, make sure that you're in the Modify menu. This is very important. And make sure that this option was selected. And make sure that you have Workobject 1 again. Now, then you need to press this. Align the active tool with the UCS coordinate. So let's do that. And you see what happened. Now, let's try to move everything down. And you can see that we can go all the way down. No issues. Let's zoom out, rotate a little bit to see what's happening. Here we are, and let's try to move to z equal to 0. Here it is, perfect, perfectly aligned at 0, 0, 0. And now you can play. You can, for example, move along the x-axis, then you can go back to 0, then you can move along the y-axis, then you can go to 0, or you can move in the plane. You can put, for example, 135 and 145. And that's it. So you will be in the plane. And that's it. Okay, that's all for today.